So differential equations are basically equations which have derivatives in them. Okay. So what you need to understand is some keywords like proportionality. So proportional means when one thing changes, something else also changes by the same factor. Okay, so if you can have a look here, if you see something is proportional to x, okay, we use this symbol that means proportional, this one here. Okay, why is it not writing? Oh, sorry, I'm on eraser, that's why it's not writing. Okay, here we go. So this symbol here is proportional. So when you have something like a derivative of something proportional to x, then we can write it as dy over dx is equal to kx. Okay. All right. So inversely proportional means as one thing is increasing, the other is decreasing. Okay. So this is how we express inverse proportionality. And sometimes you have things proportional to itself and the rate of change proportional to the amount. And then you have a situation like this. So all of the ones that you deal with in year 13 calculus will be of these three formats. Either it's inversely proportional, or it's proportional to itself, or it's proportional to something else like x. If it's not, they will actually give you the differential equation. So the ones where they tell you in words are going to be of these three types. Okay, so I'm going to do the first one here. First example, the volume of an ice cube decreases at a rate proportional to the time, and the other three I want you to quickly do the other three and just put them in the chat box. Okay. Can you ask Daddy, please? I can't do it right now. Okay, so the volume of an ice cube decreases at a rate proportional to the time. So remember, rate always means with respect to time. So the volume, okay, the rate of the volume is proportional to time. So I could write it like that. Oh, and it says decreases, so we're going to have a negative. So when I write it as an equation, it's basically dv over dt equal to negative kt. Okay, so that is basically how we write out a differential equation. So I want you to try the next one. I will put the first bit in, the population rate growing to the number of inhabitants. Now, number of inhabitants is again population. So we've got dp over dt. Okay, I want you to fill the rest. And the next one is dh over dt, and the next one is db over dt, and I want you to fill these out. You can type them into the chat box. Okay, let's write in the answer for number 2, guys. Anyone have any idea? Yep, that's it. dp over dt is equal to kp because it's increasing in proportionality to itself, which is p. Oops. And the next one, it's just 8. So there's no, it's constantly increasing. So it's just 8. Hope that makes sense. Okay. And then inversely proportional. So have a look at the table. Inversely proportional is going to be 1 over something. And it's decreases. Any answers, guys? Any guesses? You can take a guess, no harm in getting it wrong. Yep, that's it. But except we're going to have t over dt because rate is over time. So it's not L, it's t there, sorry. Negative k over I, okay? So these are basically our differential equations that we come up with. Now, what I want you to do is exercise 23.1. Of course, I'm going to post this document on Schoology for you, but if you want to get started even before I do it, it's 23.1. Okay, so next thing is the type of questions you might be given is check that it is a solution. So this is y equals e to the negative 2x. Check that it is a solution for the differential equation that's given here. Okay, now what that means is, does dy over dx for this particular function fit into the equation that I have? Okay, into this equation. So I need to find dy over dx. So that's what I'm going to do first. So dy over dx is negative 2e, negative 2x. So remember with exponential, you just, the derivative is itself, and you multiply by the derivative of the power. So that's dy over dx. Okay, so what I'm then going to do is substitute into my differential equation. Okay, so as you can see, minus 2e to the negative 2x plus 2e negative 2x is 0. So yes, it is a solution. Okay, the same applies to the next one, except what you'll see here is second derivative. It's not the first derivative, it's second derivative. So when I differentiate my y first, I get dy over dx, which is 2x. And when I differentiate it again, I will get 2. Okay, so what I'm then going to do, substitute that in. So x squared times 2 minus 2x squared. Again, you can just see that's equal to 0. So therefore, yes, it is a solution. Okay, and these are generally achieve-level questions that you will find. So this is 23.2 and 23.3. Again, I don't expect you to do every single question. Do a few of them so you start to feel confident about it. Okay, so this is the most important bit of differential equations. Well, a lot of the time, being able to do separating variables, okay, is really an important skill when it comes to applications. Now, if you have a look at my equation there, you've got dy over dx equals to x over y. The problem is, on the right-hand side, you've got two variables. You've got x and you've got y, and we're not used to that. You can't integrate one function when it's in two different variables. So what we do is called separating variables. You separate them. So I'm just going to cross multiply. So this is what I end up with. I'm cross multiplying. So I've got y dy equal to x dx. Now, if you have a look, I've got all the y's on one side and all the x's on one side. So then I can now integrate both sides. So the left-hand side, I'm going to integrate with respect to y, and the right-hand side, I'm going to integrate with respect to x. So this bit is what you're already used to. Okay, I'm really sorry about the background noise. Okay, just one moment. Okay, sorry about that. So we're going to integrate the left-hand side with respect to y and the right-hand side with respect to x, as I just said. So it's just like normal integration. You're all fairly confident with this. So add 1 to the power and divide by the new power. And here, x squared over 2. Okay, now remember, we always have a constant. So you would have plus c here and then plus c on this side. But they're just numbers and it's an equation. So if I move them all to one side, I have basically one constant. So because of that, I'm just going to put constant on one side instead of on both sides. Okay. Now, what we want to do is essentially, we want to find y. So when you integrate, you want to find the function y. At this stage, it's fine. You've got y squared over 2 equals x squared over 2 plus c. But we want to make y the subject. We're not happy with just what we have there. So then we rearrange and make y the subject. So I'm going to go y squared equals 2. So the 2 is going to cancel out when I multiply by 2. So I'm just going to write x squared. Now, I know this is going to be a little bit tricky for you to follow on at the start, but then eventually I know you will get this. So, 2 times c, it's still a constant. Okay, so I'm not going to write 2c. Instead, I'm just going to write c. It is a constant. It's not the same as the one we started with, but that's okay. We'll just leave it like that. All right, and then y is going to be square root x squared plus c. All right, so that's basically our solution to the differential equation we started with. So the next one, I'll do one more example for you, and it's again similar. So you've got, I'm integrating both sides. First, I'm going to separate my variables, dy over y equal to dx over 1 plus x. Okay, so this is a little tricky, and I chose this example because the ln bit comes in, and I know that some of you would have forgotten about it and just wanted to remind you. So when you've got y to the negative 1, we're not adding 1 and dividing by the new power, because the new power would be 0 and you can't divide by 0. So when the power is negative 1, it integrates to ln. So we're integrating both sides. So ln y equals to ln 1 plus x. Okay, now, and I'm just going to have a constant here plus c. All right. So then what we're going to do is we want to make y the subject. We don't want to have ln. We want to get rid of the ln. So the reverse of ln, or inverse of ln, is taking both sides to the e. Okay, so we're going to write all of these as powers of e. So remember, e to the ln of a is just a. So that's just going to be y. And I have got here e ln 1 plus x, okay, plus c. All right. That's a plus. Now, I'm going to do something a little interesting here. Okay, now just I want you to understand that when you have 2 to the power of 4 plus 2, it is actually 2 to the power of 4 times 2 to the power of 2. You guys okay with that? Yeah? All right. So what I'm going to be doing is, so you know how I've got this and then the plus c. So I'm going to write this as e to the c times e to the ln 1 plus x. Now, the reason we do that is because it makes it easier for us to work out the number, the constant, okay? If we write it as in the power, it's a little tricky and we can't work it out. But when we write it like this, and if you substitute the power to be 0, it's easy and it works out nicely. And that's the reason we do this. So now e to the c is going to be a number. So I'm just going to write it as y equals a e ln 1 plus x. Okay, and there's absolute values there. Okay, now, so let me just go over what I just did. So I'm hoping that up until here, everyone's okay. All right, so all I've done is I've separated the variables. So I'll just write down some notes there so you can see what I've done and read what I've done at the same time. So I've separated variables here at this stage. Okay. And then at this point, I've integrated. And what I've then done is made y the subject. And over here, I've just rewritten this, the right-hand side, and this is basically e to the c. Okay, so I'll give you a couple of minutes to just read through that. And if you have any questions, put them in the chat box. But if you're happy, just put a thumbs up. Okay, it's good to see a few thumbs up there already. Okay, awesome. All right, then. Okay, then we can move on. So now, how do you feel? Are you okay with me to start looking at word problems using these, or do you think you'd like to leave that for next one? So we'll look at a couple of problems. All right, here we go. Okay, so we have a resale value of a machine. It's decreasing at a rate that depends on its age. When the machine is t years old, rate at which its value is changing is -3,000 e to the -t over 6. So what you've seen here is they've given you the differential equation, okay? They have not asked you to express it, which is a little bit easier. So we have the value, so dv over dt equal to -3,000 to the -t over 6, okay? So what I'm going to be doing is just separating my variables. So I'm going to have dt on the right side and dv on this side, okay? So on the left-hand side, I'm integrating with respect to v. On the right side, I'm integrating with respect to t. So I should have said, the reason we're doing this, it says express the value of the machine in terms of its age, okay? And they've given us that originally it's 20,000. So what they're really asking is, can you give us a function for v? Okay, we want to work out what v is. So I'm going to integrate, as I just said, so that's v equal to, and on the right-hand side, it's an exponential, so the derivative is itself. But remember, we have to divide by the derivative of the power. So dividing by -1/6 is the same as multiplying by -6. Okay, so that's why I'm timesing here by -6. Okay, and then the plus c. So I'm going to now simplify this. So that's 18,000 e to the -t over 6 plus c. So we are told originally it was 20,000. So this is a condition they give us to help us work out the constant. So when I substitute 20,000 in, originally implies when t is 0. So when t is 0, value is 20,000. So basically, I end up getting that c is 2,000. That's not what I wanted to do. Just move. Oh my God. Oh, I'm just going to write again. Okay, so we've got C equals 20,000. So what that means is I can now write out my equation. V is 18,000 e to the negative t over 6 plus 2,000. That's my function for the value, and that's what they asked us. And usually there's another question that goes along with it, and it is how much will it be worth when it's 12 years old? So when t is 12, what is it going to be? I'm sure you guys are okay with substituting that into the calculator. So I'll leave it for you to do that. Okay. So whatever you get, that's the value of it in 12 years. So just to kind of go over, firstly, either you have to come up with the differential equation yourself, or it is given in the question. Okay. And then we separate the variables, integrate both sides, then find the constant given the some conditions. So in this case, the condition they gave us, the machine was originally worth 20,000. So they don't always tell you specifically when t equals 0, it was 20,000. So you have to understand words like initially, originally, okay, they all mean when t equals 0. Okay, or another thing is when you have kinematics, they might say things like from rest. Okay, so that from rest indicates that velocity was 0 at the start. Okay, so those are the things you need to be aware of. So using those conditions, we work out our constant and then answer the question that they have set for us. Okay, so I'll do another example for you. So let's have a look at this one. So actually what I want, so this is a case where they have not given you the differential equation and you have to write it up based on what they have said. So I want you to try and come up with a differential equation. I'll give you a couple of minutes. So when you have that, you can type it into the chat box. So the growth rate is estimated to be 0.02. Okay, I haven't got any answers yet. Any ideas, guys? Okay, do we all agree with that one or what? Just 1 second. Okay. So, yeah, I like the second one better. So they have said that the growth rate is 0.02. So, okay, so synapse is what we are looking for. I'm going to use n because they're talking about number. P is fine too. It doesn't really matter what letters you use. Okay, so I'm going to start with dn over dt equals 0.02 n. Okay, so this is the trickiest bit, I reckon, and the whole question is coming up with the equation. All right, so now we're going to separate the variables. Okay. Oops, sorry, I need to move this over to the other side. There we go. Now we're going to integrate. So on the left-hand side, we have ln of n, and here you have 0.02 t. Okay. Oh, let's not forget the constant. And then remember, we don't want ln n, we just want n. So we're going to take e on both sides. So that's going to be n e to the, okay. All right, here we go. So at this stage, guys, are you able to hear me all right, or is it a bit noisy? Sorry, that's just okay, can you, are you able to hear me okay, guys?
Yep.
Cool. All right. So at this stage, we're gonna remember this plus c bit, we just did that before. We're going to write that as e to the c. You don't actually have to show this over and over again. You can just go straight to, I'm just doing it so you understand. You can just go straight to n equals ae 0.02t, but I'm just doing this so you can understand. This is basically a, okay? So remember, 2 to the power of 2 plus 3 is basically 2 to the power of 2 times 2 to the power of 3. So here, when I've got two powers being added, I've just written them as that. Okay, so
Do you need to show it at least once in the exam to show that you understand it, or can you just write it as the
it's not something that is expected at all. You can just go straight from here to here. That's not something you need to show. Okay, so yeah, I'm just showing it and I'm making it explicit so you understand where that comes from. Now here at this stage, I need to work out the constant a. So let's go back and see what information have they given us to help us find out what a is. So at present, the number of tigers is 4,000. So what that means is I'm going to say at present is t equals 0. I'm going to substitute that in to work out what the constant is. So n equals, oh, oops, sorry, I should put that as 4,000. N is 4,000. When t equals 0. So essentially that's 1, so a equals 4,000. So my function is n is 4,000 e to the 0.02 t, okay? Now what we can do is answer the question, which is find the number of tigers in 10 years time. So n is going to be 4,000 e to the 0.02 times 10. Now, I don't want to pull out the calculator into this. I'm sure you're all able to do that. So that's essentially what is expected of you. Now, the good news is these are excellence level problems, and unless it's something very simple, like the first example I did, which is merit, but this is an excellence level problem. Okay, now just to break it down for you, you know, if you get this far, which is setting up an equation and integrating, you get an achieved level skill. All right. And if you end up getting maybe this far, you get merit. And if you answer the question, it's excellence. I'm not saying that all questions are this easy. I would say this is probably quite straightforward. Later on, I won't do them today. These are very common questions about, you know, Newton's law of cooling. We'll do that later because I think I've overloaded you with a lot of information. So we'll do that next lesson. And these are, don't be, you know, thinking, oh, this is too hard, because remember, you can all come up with the expression, the differential equation, and you can integrate this. So even just getting up to there is getting you some credit, okay? So here we go. All right, any questions about that? And if you've come in late, because I know a couple of you have come in late, I am going to post the recording and you can watch it. And you can, you know, I'm happy to stay on a bit longer if you have any questions. So if you're happy, then that's all for today, and I'll post the work on, and I'll just stay on for questions if anyone has questions. Yeah, thanks. No worries, Logan. Okay, so if you haven't got any, oh, let's see, there's more coming up. Think, no worries. Okay. Yeah. So if you have questions, just hang on, guys, but otherwise you're welcome to go ahead with your work.
Thanks, Miss.
No worries. Take care.
Bye.
No worries. Okay, so have you guys got any questions? Isha, did that make sense? Because I know you just came in quite late. Did that make sense?
The last bit did make sense, but before that it's a bit blurry.
Okay, so I'll just quickly go over what we did. Okay, so we started with, oh, I should stop the recording.